Okay, in this first video, we're going to take a look at this practice test 3 from chapter 5 and 6. In problem 1, we have a water tank for home dispensers designed to hold 3 gallons of water. Suppose the actual capacity of a randomly selected tank has a distribution that is approximately normal with a mean of 3 gallons and a standard deviation of 0.25 gallons. The manufacturer of this water tank considers the largest 5% of these tanks too large to be put on the market. How large does a tank have to be considered too large? So here we have a case where we have water tanks that are normally distributed, and what we're looking for is the cutoff, the actual amount of gallons that cuts off the upper 5%. So to find this, we can use the inverse norm, but we have to make that relative to the lower 95%. So 1 minus 0.05 is 0.95. So that means 95% is to the left. So we put our calculator on. We can do second var's inverse norm. Okay. So here it says that we want the area to be 0.95 to the left. For the mean, it's 3 gallons. And the standard deviation is 0.25 gallons. Okay, if I go ahead and enter that in, then I get a gas tank, or a water tank with 3.41 gallons will be considered too large. All right, in this next problem, problem 2, the same water tank, but now we want to know what proportion will hold between 2.25 and 3.5. So we go to here, so we can draw this out. That's a bad normal curve, but you know what I'm trying to do. So here we'll have, let's say 2.25, and here we'll have 3.5. And we're trying to find out this area right here. So that's this probability that x is between those two values. And to do that, we'll do second var's normal CDF. For lower bound, we'll put the 2.25. And oops. For the upper bound, we'll put 3.5. Okay. And we'll use the mean of 3 and the standard deviation of 0.25. So go ahead and paste that in, and I get this probability will be 0.9759 to 4 decimals. So 2 decimals would be 0.98. All right, so in problem 3, we're going to take a simple random sample of 3 tanks, and we're going to assume that their capacities can be considered independent. So we want to find the probability that exactly 2 will hold between 2.50 and 3.75. So this is binary because either it's going to hold between 2.5 and 3.75 or it's not. So it's either a success or a failure. Each trial is independent, and the probability of success is given to you as 0.9759. So here we know that x is distributed binomial with n comma p, or in this case binomial with 3 comma 0.9759. Okay, so we use the binomial PDF because this is equals 3, right? So P for the point. So we'll hit second var's and go down to binomial PDF. Okay, so the number of trials is going to be 3. The probability of success is going to be 0.9759. And the x value we're looking for is 2. Okay. Okay, so we're looking for is 2. And we'll go ahead and paste that in. And we get a probability of to 2 decimals, 0.07. Okay. Problem 4 is water tank. We're going to pick 16 tanks, and we're going to find out the probability that their average capacity will be between 2.8 and 3.10. Again, we're talking about average capacity here. So essentially what we're looking at is we have this normal distribution, and we have 2.8. This normal curve, and we have 2.8 and 3.10. We want to know the X bar probability is somewhere in this region. So because we're dealing with X bar, we know that the mean is going to be the same as the mean of the population, which is 3. And the standard deviation of X bar, or the sample standard deviation, is going to be sigma over the square root of n. So this is going to be 0.25 divided by square root of 16, which is equal to, let's see, 0.25 divided by 4. So this is going to be 0.0625. Okay, so that's our sample standard deviation. So we're going to go ahead and go to second vars. Go to normal CDF. Okay, our lower bound is going to be 2.80. Our upper bound is going to be 3.10. Our mean is going to be 3. And our standard deviation is going to be 0.0625. We plug it into our calculator. It tells us that the probability, the average capacity between those two is 0.9. 2 decimals will be 0.94. Okay.